Hey everyone, today I want to talk to you about a very exciting topic of image caching, container image caching to be specific. It's exciting, I promise. No, but really, if you're running any sort of production Kubernetes workloads, you want to have control of your image repository. That's where you're pulling all your images from. The registry you have is yours, and uptime is something you need in order to make sure that you can scale your clusters out. If you want to move those repositories closer to your accounts where you're pulling them from in region, say, that's going to be something that you're going to have to do. And if you're relying on upstream third-party repositories and registries, you don't control those. And in some cases, like the Kubernetes registry, which is a fantastic service, it is a free service that's run by community members, and there is no SLA for uptime on it. If it goes down, you can't scale, you can't build images if you're relying on it. So I want to talk to you about image caching. And what we have is called a pull-through cache. You can do caching and mirroring a lot of different ways. ECR just announced a new feature for using the upstream Kubernetes registry as a pull-through cache for ECR. I want to show you how it works. I want to show you how you can use it and a few different ideas on something you might be working on just to make sure that you can scale your clusters and their performance. So I wrote this blog post. It has all of the examples that we initially thought that people would like to have, depending on how you're using your images. I'm going to walk through just a couple of them in this video to show you how it can be used. And the first thing we need to do is just turn it on. So let's look over here in my registry. You see I have no repos, no images available right now. I'm going to click on the private registry right here and then pull through cache. We have to add a rule for where we're pulling from. And so the public registry we're going to pull from is Kubernetes. There's also ECR public and Quay. Those have been there for a little while now. And we have a default namespace here of Kate's. I'm going to go ahead and leave that, but you can change it to whatever you want. Once we save that, you can see here that all of my images are going to have this Kate's / upstream image name. So I have a registry, which is my URL. It's account name in my region, all of that stuff. I'll have a /Kate's and then a /image. And let's say I'm pulling the autoscaler, the cluster autoscaler. That's going to be a /cluster -autoscaler : and then the tag. I'm just going to append that to the end of whatever my registry and Kate's namespace is. So let's show you how we make the first image and pull it from an upstream repository. First, we need to log in, of course. So we're going to log into my ECR registry, and you can see here, this is the URL for the registry itself. And then we just need to pull an image. Let's say I'm going to pull the metric server. And I'm going to pull the 0.63 version. And this is just a standard Docker pull. Here is my registry URL. Here's that Kate's namespace. And then here's the piece that usually would be after registry.kates.io. So I don't have that image existing, but when I pull that, I'm going to tell ECR, say, hey, I need this image. It's going to go upstream and fetch that image for me, pull it down in ECR, and then serve it back to me. And you can see here, if I switch back over to my registry, I will have a repo now that has that metric server available in it. And something important to note here, I only pulled the 063 tag. So that's the only tag that's in here. It's whatever layers are required for that 063 tag. So nothing else gets pulled in with that. I'm not getting the entire image with all of the tags. I'm just pulling the one that I need. I'm mirroring it here or caching it here in ECR. And now it's available for me to use. So let's go ahead and use it. I have a Kubernetes cluster. You can see I have nothing installed. Let's go ahead and install that metric server using the Helm chart. So the metric server has a default Helm chart. And what we need to do is we need to set a variable to say, hey, we're going to use this chart, but I want you to come from the registry that I'm going to provide to you. Upgrade. And here's in my cache. We can see here I'm setting this image.repository variable to the place that I'm storing it now. And this is in US West 1 where I pulled it down from, and we'll say create namespace. That's going to go ahead and deploy that Helm chart, and it just overwrites that variable at deploy time and says, okay, you need the image to come from somewhere else. And as we would expect, that's going to pull down and get it from my registry. Now let's say I have a different cluster in another region and I want this image to be available in that region too. And I don't want to pull from, let's say, Oregon US West 2 from US West 1. The cool thing about having this in ECR is there's a feature for that already. So if I look at this private registry, I can go to replication. Replication has rules that we can add on what we want to replicate where. So I'm in US West 1. I'm going to say I want cross-region replication from this region. And so I'm going to replicate to other regions from here. So anytime I pull an image, it'll be pulled down here and then replicated to the other regions. I could also go to other accounts, but I actually don't need that here because I can set up IAM permissions to pull from my centralized accounts in those regions once it's available in the region already. So all I'm going to do is do cross-region replication. Click next, and I'm going to replicate this to US West 2 in Oregon. I can click as many of these as I want. Standard rates apply for storage in those regions, and then a filter for what is going to be replicated. In this case, it's everything in my Kate's namespace. So this is a filter for anything that gets, any repository that gets added in this region under that Kate's namespace is automatically going to be replicated somewhere else. We can also see here the JSON for how this works. If I want to do this through the AWS CLI or Terraform or something, it's a prefix match on Kate's. We'll submit that rule. And the thing to note here is if I go over to the Oregon region, go back into ECR, and we will see that I actually don't have any images there. I don't have images because, oh, actually I have old images. These were from a previous recording of this, and pay no attention to it because this is actually the third time I'm recording this for various reasons. So let's get rid of all of those. And now we have nothing. And so replication only happens when I pull the image. And so in order to do that, I'm going to go back into my terminal and let's pull a different tag here just to show that we're going to pull the same tag. I'm still in West 1. That's where I'm authenticated, is to West 1. And this image or this new tag is going to be pulled through West 1. It's going to get the tag and store it in that region, and then it's going to replicate it to my other regions that I defined. And so if I just wait a second for it to actually do that replication process, it's not instant. It does have to send some bits over the wire, and it's a lot faster than a plane ride, though, I'll tell you that much. And so here we go. We have the metric server. If I click on it here, I will have once the tags and everything finishes, I will have that 062 image tag here. So now I can pull this image in the Oregon region. And if I have a cluster there, I didn't have to wait for myself to pull it in that region either. Now, if I'm replicating this across a lot of different regions, one thing that I hate doing is trying to remember what region I'm even deploying to. And so in order to fix that problem, we can actually go into the cluster and set up a policy that will rewrite our image destination or our pull for us automatically. So let's look at Kubernetes, which is actually called out in the blog post. I have a whole example for it. Shout out to Jimmy on my team for helping me with that policy. That was awesome. And so if we install Kubernetes in the cluster, which I already have, and then here's an example policy that we can look at. Open up this policy, and this is going to show us everything that we're going to look for. We're looking for this key here under registry case.io, and we're going to rewrite that to my registry with a /Kates as the namespace, and everything else is just going to prepend at the end. So everything after that registry name is going to come here under image container element path, and also the tag. And so we can see here, this is for containers, but I'm also going to do it for further down here, init containers. You could do it for sidecar containers, anything you want to rewrite with that new URL, you're going to put here in this policy, and we're going to apply that to the cluster. I actually already have Kubernetes in this cluster, so all I need to do is apply that. And now that it's applied, I can go ahead and pull another image and see how it gets rewritten. But in this phase, I actually still need to pre-populate my cache. And so let's switch my region back over to Northern California, and let's pull the BusyBox image. I know the K8s registry has a BusyBox image at the root, and I'm just going to pull the latest image just so that that gets cached in my repo. Back in Northern California, refresh this, I see my BusyBox image, and now let's deploy a pod. I have this pod definition here, and I'm explicitly leaving this as registry K8s.io with BusyBox, and so we can see how that gets rewritten when we apply it. And then once we describe that pod, we can see that we're pulling something that's not registry.k8s.io. This is, of course, our registry. Kubernetes went ahead and rewrote that image for us and then applied it in this region. So each region you have a cluster, you can have different policies that automatically do this for you. So you can rewrite those image policies for you automatically. And the last thing that I really like to do is, again, I don't like to think about even what images I have cached or don't have cached. So in this case, I'm going to set up a IAM permission to allow my Kubernetes worker nodes to pull any image from upstream. This is going to work with IAM permissions that it needs a create repo policy. So I currently cannot pull any image I want unless I pre-populate it, because the nodes, when they try to make a pull through cache, actually need to do an IAM create repo policy or call to be able to initially create the repo. In this case, you don't really want to do that in production. So I'm going to do this for a test cluster where I typically test out images. So anytime I need to update an image tag or pull down new things to try them, I'm going to do that here in my test cluster, and then that gets replicated across multiple regions. And the production accounts don't actually need, the nodes in those production accounts don't need the create repo policy. They're fine with read only. And my cluster that I do my testing in a dev or test environment has that access to do this sort of pull and create repos. So in order to do that, I'm going to jump over to EC2, and I just need to find the IAM permissions that my nodes are running with. So if I look under instances, I have a PTC node here for pull through cache. Let's go down and find the IAM role that it's using. Oops, too far. Subnet IAM role. There we go. Let's open this up, and then in the blog post, I have, of course, an example of what you would need. This is example IAM for pulling images across multiple accounts, but I have, here it is, IAM policy right here for the ability to pull down new images basically through a pull through cache. So I'll go here, and we're going to add a permission and create an inline. And drop the JSON. Create repo. Create policy. And now my nodes have permission to pull new images through that cache, which create that image. So let's go ahead and deploy the node problem detector. This is a fun one from upstream. I know those images are stored in the upstream registry. There's a Helm install somewhere in here that I need to find. Helm, there we go. I just need this. And in this case, I'm going to run this Helm install without overriding any of the image names, because I have that Kubernetes policy that's automatically going to rewrite that registry.k8s.io to my local registry in this region. Once that's created, it's going to then trigger it in the pull through cache. And let's just jump real quick back into here. I'll go back to ECR and show you again, I don't have this image available in my repos. I just got BusyBox and metric server. But if we do this Helm install, I will get that daemon set that goes out. And now I have, oh, my BusyBox, oh, it's failing because I told it to sleep for a couple seconds. So if I look at this image, or this pod here, you will see that we are assigning it, and here is our container image. And it's present on this machine because I did pull it. But if I go back here, oh, my image pull policy isn't set. Let's Let's delete a node. That's always the fun part. So in this case, we can see that I actually didn't trigger the pull through cache because it says it's already present and I don't have a policy to always pull that image. So the only way I can do that is either change the Helm chart and say, hey, I want you to always pull this image, or delete a node or clear the cache on a node so that that image gets removed. And that does happen on occasion. There's basically a kubelet that cleans up some of those old images, but I didn't wait long enough between recordings to trigger that. So let's force it to trigger, and we gotta wait for both my nodes to get available. I already have the daemon set deployed. And so this is just a matter of, as soon as the node comes up, the daemon set will automatically go to that node and that will trigger the pull of that image. And it looks like I have a new image now. It's been available for 17 seconds. Let's look for which pod is 22 seconds old here. And although I don't have my network ready on this node yet, you can see that it pulled this image finally for us. So when I go back into ECR and refresh, it was able to automatically create the new image cache for me. So I have permissions now in this node, in this cluster, to create those permissions and pull through any image that I need. And again, going back to, if we wanted to look at Oregon, that image also gets replicated here because of the rule. So even though that node only has permissions and it's creating a repository in one region, I get that image everywhere based on that pull. So my cluster in Oregon can still remain with read-only access to ECR. So thanks so much for checking it out. I really hope that this feature helps you out with not only scaling with having better performance from image pulls, but also just from availability. So if any upstream images are being replicated inside of ECR, you get a lot more control of that, a lot more performance, and a lot more just guarantees around that uptime. Again, because this isn't a community run repo, you can get support and guaranteed SLAs with uptime for these images so that you can pull them down and scale with them without having to worry about doing manual mirroring and figuring out which images are needed. So check out the blog post. Really hope you enjoy, and see you next time.